So with this particular worksheet, some of the questions you'll be able to work on yourself. We have done these in class and you did them with the previous worksheet. A few of these that I have starred, 5, 6, 9, and 10, are a little bit different. And the reason for that is everything that we've looked at so far has been a fairly simple circuit. I have electricity leaving the battery, goes to the load, in this case I'm calling it a resistor, and then travels back. On these other problems, we are adding more than just one electrical load, whether it's a resistor or a light or whatever the case is. And because at this stage, circuits can operate in a couple of different ways. One of them is as a series circuit. And that means the items are just daisy-chained one after another. So if I was going to draw out what would number 5 look like, okay, number 5 is using 2 batteries running through a wire to a resistor and back. And when we connect a battery in series, we are taking the negative of one battery and tying it to the positive of another battery. And what that does is that it increases the voltage that's in the system. So for number 5, if we have a 3-volt battery and a 12-volt battery, we're going to add those voltages up, and from there we can solve the problem and find how much current is going through that particular resistor. Number 6 is a similar arrangement. In that it is a series circuit, and we have a battery source or a power source, and it is going to have 2 lamps wired one after the other in a series circuit and then back to power. Each of these lamps has 3 ohms of resistance. And when these loads are in series like this, like we did with the battery, we just add them up. And I'm going to call this resistance 1 and resistance 2. And that's how we can do 5 and 6.